Hey guys, it's Miss Smith here, and today this video will be going over the Punnett square word problems. Now, this is assuming that you have done this critical reading and you've also done the Punnett square monohybrid practice. All right. If you haven't done these assignments yet, I would highly suggest doing those assignments first before you delve into this video, because I'm going to be using vocabulary based off of those assignments. So if you're unfamiliar with what I am talking about as I go through it, again, I highly suggest going back to those assignments. Okay, so here we go. Now, I know when it comes to word problems, not just in science, but also in math, some of us tend to get a little not scared, but just a little intimidated by what the question is asking, because we're unfamiliar with either A, the vocabulary, or B, what the question is specifically asking us to do. So in this video, I'm just going to break down some of the word problems on what it is asking you to do. Okay, so here we go. For each problem, draw a Punnett square, write the genotypes and phenotypes of the offspring using the alleles given. Okay, so basically what you're going to do for each problem is doing those three things. Okay, and I'm going to show you what that's going to look like. Here we go. Number 1, predict the genotypic and phenotypic outcome of offspring of a cross between two heterozygous tall pea plants. Use use capital T for tall and lowercase t for short. Okay, so first things first, I'm going to draw a Punnett square. For those of us that are doing this by paper, obviously just draw it out. For those of us that are doing this digitally, here's how we're going to do it. You're going to go ahead and do insert. You're going to do a table, and you're going to do a table. You're going to do it 3 by 3. Okay? Now, what does a cross mean? Okay, so all we are doing is we are crossing two heterozygous. Remember, heterozygous it means two different. It means different. So I need a capital T and little t, and it says I'm crossing two of them. So that means both of the parents are heterozygous. Okay, so capital T little t for one parent and capital T little t, little t, sorry, there's a hair, for the other parent. Just blow this up a little bit. All right. Now, let's go ahead and plug this information into our table. I'm going to go ahead and do center this. And this one I'm going to go ahead and do a right alignment just so it looks a little neater. Okay, so for parent 1, we have capital T and a little t. And again, we always want to make sure that our work is in a different color if we are doing this digitally. And parent 2 is the same, they are heterozygous. All right, so now I'm going to go ahead and cross them. So for this first box, I have capital T, little t, and again, this shouldn't be anything new if we've done this assignment. Okay, I'm going to go ahead and cross this one and this one. So that should give me capital T, little t. I'm going to cross this box and this box, which will give me this, heterozygous. And then the last one is going to be crossing this allele and this allele, and I'm going to get this right here. I'm just going to make this font just a little bigger for those of us that need to see it. Okay, so this is what our Punnett square should look like. Okay, so we've done the first part. Now we need to go ahead and write down what are the genotypes and the phenotypes. Again, this part should not be particularly difficult because, again, if we've done this assignment, it should be a piece of cake. So let's start with our genotypes. Okay, so my genotypes are going to be, it's going to be the code. So what are all my possible codes? Well, my first possible code is going to be a capital T, or homozygous dominant. My other option is going to be heterozygous dominant or capital T, little t. Now, I noticed that it's in 2 boxes. I'm not going to repeat that twice. I'm just going to consider that as another option, so capital T, little t. And then finally, my last option is going to be homozygous recessive or little t, little t. Okay? Now, remember that each box represents 25% of the outcomes that we are going to get. Okay. And it'll make sense why I did that in a second. Okay. So I know that for this assignment, it did not ask us to do ratios for the genotypes, but for this assignment, we're going to go ahead and do that. So of this genotype, we have 25%. There are no other possible chances of it being capital T, little t. So that's going to be 25% for this option, for for homozygous dominant. All right. For this box right here, this option where we have heterozygous dominant or capital T, little t, I have 2 boxes. So I have this box and this box. And remember, if it's the same, we're gonna go ahead and add those percentages together. So 25% and 25% is going to give me 50%. All right, and then lastly, we have the final box for homozygous recessive, and it's just the only one of its kind, so 25%. All right, so genotypes are done. Now I need to focus on phenotypes. So my phenotypes. Now remember, we have to look back at what these represent. Well, according to what the directions gave us, capital T is for tall and a little t is for short. Now, because capital letter is dominant, and for dominant you only need 1 to be present, those boxes that have at least 1 capital T, that have at least 1 dominant, are going to represent tall. So this represents tall. This one as well, even though they are different, right? Even though this one is homozygous and this is heterozygous, there is at least 1 capital T. So that is going to be represented as tall. Same thing with this one. And then finally, for homozygous recessive, remember recessive, we need both of them, both alleles to show, to be present in order to see that trait. So short. Okay. Now we can go ahead and answer this question. So for phenotype, we have this box for tall, this box for tall, and this box for tall. Remember, just because the genotypes are different, right, the phenotype itself is still the same, regardless if you have homozygous dominant or heterozygous dominant. So I'm going to add all these boxes together. So 25 plus 25 plus 25 is going to be 75%. So 75% of the offspring are going to be tall, and 25% of the offspring are going to be short. And I'm going to change this to and as well. All right. So that's what my answer should have. It should have the cross, the parents, the Punnett square itself, and then of course the actual answer to what the genotypes and phenotypes. Again, with the percentages, with the likely outcome of what is what, okay? So I'm going to just move down to number 2. Okay. In pea plants, yellow peas are dominant over green. Predict the genotype and phenotypic outcome of the cross between a heterozygous for yellow peas and homozygous for green peas. Okay, so same thing, same setup, right? We're gonna do a cross. Okay, but remember, it is asking for heterozygous yellow peas. So in this one, it wants us to use P for yellow, capital letter P for yellow and lowercase p for green. So our first parent is heterozygous. So that means I need to have a capital P and little p because, again, heterozygous for the first parent. The second parent is homozygous for green, and green is represented with a lowercase p. So if it's homozygous, that means both of the alleles are going to be little p, little p. And I'm not going to go over how to do this cross. I'm only just going over what you are crossing based off of what that question is asking. So let's move on to number 3. Okay, predict the phenotypic and genotypic outcome of a cross between 2 heterozygous for yellow peas. Use the alleles from question 2 above. Okay, so what does that mean? So we're using the alleles that are in number 2. So all you're doing is using these alleles from number 2. So again, if both of the plants are heterozygous, that means both of the parents are heterozygous. So parent 1 is capital P little p, and parent 2 is also capital P little p. And again, I'm not going to go over how to do the Punnett square or how to figure out the ratios. That you should already know how to do at this point. Okay? Okay, the next one, it's the same as number 1. You're just using a different allele, in this case for round versus wrinkled for the plant. Sorry, my cat is like climbing on my desk. Haha, speaking of cat, number 6. All right, one cat carries heterozygous for long hair, and its mate carries homozygous for short hair. Use a Punnett square to determine the probability of their offspring having long hair and the probability of their offspring having short hair. Again, if we're seeing that word probability, all you are doing is, again, you're just answering everything with all this information. Okay? Probability is represented in this case as a percentage. So what percentage is going to be long hair? What percentage is going to be short hair? Okay. I think for the most part, right, that all of these should be pretty good to go. All right. If you read through the problems carefully, you should be able to do all of these problems. Remember, look out for the words heterozygous versus homozygous. Which alleles do you need to use? And make sure you are setting up your Punnett squares in the correct boxes and the correct spaces. All right, I hope this video has been helpful to you. And I hope you have a wonderful day, evening, depending on when you're watching this. Bye.